they want to hear this. Happy Valentine's Day. Prepare the answers to today's quiz. What is Cousin Planus referring to? Flat feet. The most common joint disease? Osteoarthritis. Osteoarthritis. Define diarthrosis. A freely movable joint. Define arthrology. Study of joints. Define kinesiology. It's really study of movement, which includes muscles, joints, bones, but study of movement. Good. Standing on your tiptoes is called, very good, plantar flexion. Where if you were pointing your toes up, it's called dorsiflexion, but on your tiptoes is plantar flexion. Great. Turning the palms of your hands toward the back, pronation, palms posterior is pronation, right? Anatomical position, it's called what? Supination. Pronation, right? What is and what is the function of the meniscus? What a weirdly worded question. Okay, sorry. This is really good. Trying to write these questions so fast. Okay, so what is a meniscus? What is a meniscus? It's a fibrocartilage pad. And what is its function? The cushion between two bones, the ends of two bones, right? The cushion. It's an extra cushion. So what is a bursa? It is a synovial-filled sac that allows for the gliding of tendons over the joints. Good? Okay. Name an autoimmune disease that may lead to arthritis. Because we said arthritis just simply means, it's an umbrella term. It just simply means pain or inflammation in the joint. But there are many things that can cause it. So an autoimmune disease, we've mentioned the most common, probably rheumatoid arthritis that you think about, that can happen at any age. But also we said lupus can affect the joints, psoriasis can affect the joints. So you might put anything else. What'd you say? Lupus. Yeah, it said lupus and rheumatoid arthritis and psoriasis. So those are autoimmune diseases. Joints are levers, and they give us mechanical advantage that will either be what or what? Power or speed. Right. And then you had another chance at a bonus where I asked you what is the formula. MA is equal to the length of the effort divided by the length of the resistance arm. And you won't have to do it. It's already been done. You know, they've already studied every, this anatomy of these levers, these joints. But we know at each joint what we expect at that joint. And so if somebody has lost their range of motion at that joint, could it compromise their, well, certainly it could compromise, but like their life, it couldn't, like they may have to stop doing certain things. So this is the problem, right? And we try to get them back function if they have lost function at a joint. Were these fair questions from the lecture the other day? These were pretty fair. If you did not get these answers, then just make sure that you know them before the next class, okay? Because you will have, like, all of those motions. We'll talk about y'all know what abduction is and adduction, don't you? You know what opposable means. What is that referring to? The thumb, being able to pick up things, right? And you know those terms. I can promise you questions in those terms. Okay, so do you have any questions for me before we continue today? Do you have any questions? All right, so we're going to actually talk about muscle physiology today. We started this the other day with our story on skeletal muscle and what it takes each time, Mariah, could you close that door? Thank you. Sometimes it's louder. Each time a skeletal muscle, you give a directive, because it's under voluntary control, you give a directive to do something. This story has to happen from the very beginning, which requires a motor neuron functioning. to the very end where the muscle relaxes, which took several things happening for the muscle to relax. But that story has to be complete, or you're going to be compromised in skeletal muscle innervation and movement. So we started that. I'm going to go over it a little bit again today, but I wanted you to know that's what most of this chapter is all about, is really skeletal muscle, because we're going to have an entire section on the heart and the cardiovascular system. But I will remind you of some differences between skeletal muscle and cardiac muscle, and again, even smooth muscle. So most of this chapter is really dealing with skeletal muscle and the innervation and the function of skeletal muscle. So we said this is an entire category all its own. Most of you all, I said I'm always impressed with you all at how you become histologists with just one lab. You did a great job, so congratulations, it was amazing. You know that muscles are a category all themselves of tissue, because muscles have this ability to actually contract, don't they? So whether it's cardiac, smooth, or skeletal, they have this ability to contract. But really, almost as important is that they have the ability to go back to their original shape and relax as well. So this is something that they have the ability to do. And I think almost everybody got that this was muscle and that it was skeletal muscle. They saw these striations, right? Under voluntary conscious control, we know that about skeletal muscle. As far as the anatomy, and you're looking at some of this anatomy of a muscle fiber, I'm not having you label this, but let's see if there's some things that you might actually, it might sound familiar to you. So when you talk about the fluid of a cell, we call that cytoplasm, right? You don't have to write this down, it's just FYI. But if you're talking about muscle, it's called what? Sarcoplasm. And then when we were talking about the endoplasmic reticulum, this membranous network, we called it here what? Sarcoplasmic reticulum. So these are just some common things. Do we know what mitochondria do? Mitochondria are the powerhouses of the cell that supply most of the ATP that the cell's going to need. And certainly muscle is going to need numerous mitochondria, aren't they? So, because so much is going on. Now, I had introduced you to the idea that there are two contractile proteins. One of them is a thick filament called myosin, and the other one is a thin filament called actin. So I had told you that the two contractile proteins in muscle is going to be actin and myosin, and they're kind of interwoven. The best place to see it is like on a diagram like this, where you have the actin and the myosin here. So myosin's kind of thick, the actin is thinner, and at rest they're just sitting there kind of interwoven. Is that right? And at rest they're not contracting, but that's actually, you don't want them contracting willy-nilly, do you? No. And so we said what actually controls the contraction is going to be these regulatory proteins called what? Troponin and tropomyosin. And here's the regulatory proteins, troponin and tropomyosin, that you see. And what these little regulatory proteins are doing are actually blocking the binding sites on actin. So at rest, the binding sites are hidden. But we said we know that there's something that can interact with this troponin, tropomyosin to move them away from those binding sites. What did we say that was? Good job. Calcium. And we said that when calcium is present, it will actually, okay, well, I don't see any great pictures right here, but I will in a second. When calcium is present, it's going to cause these regulatory proteins to move out of the way so that these cross bridges can be formed between myosin and actin. And when the cross bridges are formed, what's it going to do? It's going to pull them together, right? It's going to pull those filaments together. And when they get pulled together, what the entire fiber does what? Contracts. Any questions from you about that so far? Okay, so I had introduced this a little bit to you. Here is, here's obviously an illustration where, they're not contracted yet, so you have this space. But when they do start forming the cross bridges, this space is going to become much shorter, isn't it? Pulling the entire fiber to contract. These filaments, actin and myosin, are attached to the muscle fiber by another special kind of protein called dystrophin. Now, you maybe want to write that down. That's called dystrophin. So that when these filaments do contract, the dystrophin's holding, which is a protein, is holding them attached to the outer membrane, so the entire fiber contracts. What disease do you think it is that's inherited? It's an inherited disease that you have an abnormal molecule of dystrophin, so it doesn't really hold these filaments to the fibers. So the actin and myosin might be forming cross bridges, but because they're not attached to the membrane, there's no real contractions happening. What disease do you think that's called? Muscular dystrophy is an inherited disorder of the dystrophin. That is that protein that holds these filaments to the fibers. So what happens in muscular dystrophy, which you all do want to know this disorder, it's an inherited disorder of dystrophin, is that what happens is that over time, like in the beginning, in little toddlers and little kids, the muscles are kind of working. But over time, the skeletal muscles, because they're getting the signal from the motor neuron. There's motor receptors on the membrane. The receptors open, sodium pours in, potassium pours out. They're getting the whole deal. They're getting the whole contraction and relaxation. But because the muscle's not contracting as it should, if it's not happening over time, it's getting replaced by adipose. So over time, the muscles weaken. Muscular dystrophy, the main type, there's about 9 different types, but the main type of muscular dystrophy, those kids die before they're 20. This is a devastating disease. You know, so this is a devastating disease, isn't it? And it's mostly of males. So where do you think the information is held on your chromosomes? The X chromosome, that's the 23rd and the 23rd pair, right? So these males inherit this from their mother. And yeah, it's a devastating kind of inherited disorder. It really is. So there are other types of muscular dystrophy that aren't as devastating and can certainly be seen in males and females, but less common in females, and we know why, because it's a sex-linked disorder. So if you had understood that genetics, you know, we'll talk, we did kind of follow me here. So, okay. So we said this is, so now I told you it's sort of, we're still talking about normal physiology, but I hope that that kind of went along with that. So we did this. Now let me tell you what you have in the book that I think is just really nice. I think this is just really nice. We had said that for every, and I won't go to it, but I might come back to different pictures. Let's look at this first thing. We said that for every muscle contraction, and I want you all to bear with me for a second. This is the muscle fiber membrane. You see where my finger's going here? The muscle fiber membrane is here. These are the actin myosin sarcomere units, whatever. These are the actin myosin interwoven things here, the myosin, the thick one, the actin being the thin. What is that? Okay, somebody's happy. Go ahead. So, okay. So this is the muscle. This is just a little piece of the muscle fiber. So, you know, obviously this is a big, long muscle, right? This is the end. This is the end of a motor neuron. So you all remember those motor neurons that were, you know, had like the octopus-looking appendages off of them? You know, yeah, most of you all got motor neurons when you looked at histology. So this is the end of one of those things. And at the end of this motor neuron, it's referred to as the axonal end, because this is the axon. There are these little vessels inside the cells, and in these vesicles, there's a neurotransmitter. And through exocytosis, this little neurotransmitter is going to be released into this space. What did we call the space? A synapse, right? And so as long as the motor neuron is functioning, making these vesicles that have this neurotransmitter that we call acetylcholine, these can be released into the space. That's our first part of the story, wasn't it? And what we know is that if they're released into the space, if this is released into the space, what will happen is these little acetylcholine will actually bind in the receptor on the membrane of the muscle. And when it sits here in this receptor, it's like a lock and key. So what's the receptor going to do? Open. What did y'all say pours in? And if sodium comes in, there's already a ton of potassium in there. It's got the same charge. So what's potassium going to do? It's going to be repelled. And that's going to send a shock. That's called an action potential, isn't it? That action potential, when the shock gets sent, what's the reticulum going to do? Release what? Calcium. Calcium's going to flood into these areas that have the actin and myosin sitting there. And you all told me that then the calcium's going to act on the what? And when the calcium does that, it's going to cause troponin and tropomyosin to move away from, you see these little binding sites that are now open on actin? And those binding sites are now open on actin, so cross bridges with the myosin can form. And it's going to bring those filaments together. And that's a what? That's a contraction happening. You all told me to break these cross bridges, you needed what? You need ATP to break the cross bridges, didn't you? You needed ATP to break the cross bridges. But also, when we're thinking about ATP breaking the cross bridges, we said at the same time, this acetylcholine, this neurotransmitter, is being diluted in the synapse. I do want you to know that there's an enzyme called acetylcholinesterase that's also breaking it down, chomping it up, because it's had its day, it's time to go, right? So acetylcholinesterase is breaking down acetylcholine. Acetylcholine's being diluted. And then what did we say calcium is doing? Migrating back to the reticulum. Do you see that? All those steps are part of the relaxation. ATP breaking the cross bridges, calcium going back to the reticulum membrane, ACH being diluted, and ACH being broken down by acetylcholinesterase. All four of those things are happening for the relaxation. Is the relaxation phase just as important to know as the contraction? Yes. Yes, because that's a cycle that has to be fulfilled, right? They all have to be working perfectly. So what I'm going to get you all, have an opportunity to do, and this is the only thing as far as lecture quiz that will be Tuesday, because I know Tuesday you'll also be studying bones, won't you? For bones, you'll be looking at those bones, and you'll be doing that, and I get that. So for Tuesday, I want to give you this opportunity to, on a lecture quiz, bring lecture quiz grades up if you need to. Some of you don't need to, but if you do need to, that's fine. What you're going to do is tell me that story. And you're just going to write that story for me. Once upon a time, there was a functioning neuron that was able to release acetylcholine, ACH, you can write, into a space called a synapse. When it crossed the synapse, it met with a receptor protein on the muscle fiber. That receptor protein opened. What poured in to the fiber? Sodium. In response to sodium coming in, what poured out? Potassium. What did that cause? An electric shock to move through the fiber, through the whole entire muscle fiber, including the reticulum, the sarcoplasmic reticulum, endoplasmic reticulum. When that happened, the reticulum released what? Into the muscle fiber. Calcium acted on troponin and tropomyosin, which unlocked the binding sites of actin, so that now actin and myosin could form cross bridges and contract. What broke the cross bridges? ATP broke them. At the synapse, what was happening? The door was closing because calcium, no, the door was closing because ACH was being diluted and being eaten up by an enzyme called ACHE. Aaron said acetylcholinesterase. Yes, that's fine. And at the same time, calcium was migrating back to the reticulum, the membrane. That's the end of the story. How are you feeling about that story? How are you feeling? Do you understand that one thing happening caused the next thing to happen? Does everybody understand there was cause and effect? Does everybody understand you don't memorize this, you let it make sense to you because it's sequential, right? The one thing happens that causes the next thing to happen, and that because of that, we know that if one thing gets interrupted, is it going to affect the next outcome? Is it going to sort of block or stop the next outcome? Yeah. All right.
So when you have a cramp, what is being affected?
So look, guys, this is a typical what happens in a normal skeletal muscle contraction. We understand that there are other electrolytes that can play a role that can actually cause some cramping types of situations. So it depends on what types you're talking about. But we do know that there's some other things that can influence that. So when electrolytes are off, when fluids balances are off, can that put people into sustained contractions, cramping? It can. It definitely can. So yeah, so we know that. Okay, all right, now I want to go back, just make sure I haven't missed anything that I know that I hold you responsible for. If I haven't said it, I'll throw it out on the test, won't I? That's why you all study the lectures and the lecture notes, and that's why y'all study insights and disorders, because you know exactly what to study for this class, hopefully. You're trusting me at this point, right? There is something that I want to bring to your attention that this should make perfect sense to you. So when we are exposed to pesticides and some other chemicals that inhibit or bind to the acetylcholinesterase, so the esterase was what was breaking down acetylcholine. So if acetylcholine is not getting broken down at that synapse, we said that's going to affect the relaxation period, isn't it? Isn't that going to affect the relaxation period? It is. So that can lead to what's called spastic paralysis, which means a contraction, but spastic. So sometimes paralysis are flaccid, but sometimes they're spastic. So certain pesticides, certain toxins, there's toxins that some bacteria produce that can cause spastic paralysis. This would not be a good thing because it can lead to suffocation. Do we have to have muscles for inspiration, for breathing in? Yes. So if these are not functioning as they should, then it can actually lead to suffocation. Tetanus is a disease, and I do want you all to know that tetanus is a disease that's caused from a bacterium called Clostridium. Clostridium is the genus. The species name is tetani, T-E-T-A-N-I. And this particular bacterium produces a toxin that overstimulates the muscles. So this, again, a spastic paralysis. And so we do not want those things happening. You can also have flaccid paralysis, which means that the muscles won't get the signal to contract. That would be also very bad, wouldn't it? So flaccid paralysis can happen because of, again, certain poisons. Y'all have probably heard of curare. Poisons, but also it can happen because of toxins from another bacterium. Have y'all ever heard of Clostridium botulinum? Now this is the same genus, Clostridium, but I want y'all to write this down. But the species is named botulinum. What do you think that bacteria causes? What disease? Botulism. But in botulism, you have a flaccid paralysis instead of a spastic one. What do people call tetanus? Oh, here it is. It's up here. They call it lockjaw, right? That's what some people call this. But anyway, because a lot of times these muscles of the jaw, the first ones noticed that are spasming. But anyway, so Clostridium tetani causes the toxins cause a spastic paralysis, where Clostridium botulinum causes a spastic paralysis. What do you all know that toxin from Clostridium botulinum? Have you heard of any medical reasons to use that, and what is it called? Does anybody know? By the way, the toxin from Clostridium botulinum is the most powerful natural toxin, the most potent natural toxin known to man. Botox. It's called Botox. It is. And so has man been able to take this bacterium, get the toxins, purify the toxins, and use it for medicinal reasons? Yes, they have. People are using it for migraines. They're using it for all kinds of different GI issues. Now, should somebody know what the heck they're doing when they're using it? Because this is a very powerful toxin that can cause spastic paralysis, if you would want, you would want somebody knowing what they were doing, right? Certainly, you all have also heard of it being used for cosmetic reasons too. Okay. So yeah, that's that. But mostly, do we want things working like they're supposed to be working and just right? We want the contraction to happen just right, and we want the relaxation to happen just right. We don't want overstimulation. We don't want understimulation. We want it to happen just right. And we need our electrolytes: sodium, potassium, calcium. We need those electrolytes to be balanced in our system, don't we? We need the fluids that are bathing our cells to be level. We need all of these signals to be sent. Anything that can depress the nervous system, whether it is a natural thing or a legal, prescribed, or whether it's illicit, anything that can depress the nervous system, can it affect your entire muscular system? Yes, it can. Or anything that overexcites it, would that be bad too? Yes. So, so good. Does anybody have any questions about the story? Anybody have any questions? Y'all can, if you do, then what I would suggest today when you all are start looking at bones again, is and muscles, beginning your look at your muscle list, is to check each other's stories. Maybe tell them to each other. It would only take you a minute to say it to each other and make sure everybody kind of had it down. Check your friends to make sure that everybody's got it. It would be just a nice thing to do. I told you what rigor mortis was, didn't I? If you know that storyline, rigor mortis is perfect, makes perfect sense. Look, so isometric and isotonic contraction. You guys have probably heard of isometric exercise, haven't you? But anyway, these are terms that just know basic. This is just definition, so it's terminology. And isometric muscle contractions, there's tension forming, but without changing the length of it. So if I ask you all to all go back to the back wall and move it out into the hallway, you all would be back there pushing, but really, would anything much happen? No, not much would be happening. Isotonic exercise, there are a couple of different types of it, where shortening and/or versus lengthening, and both would be important. But I don't care that you know the other, just that you know the difference between these two. So isometric, there's very little movement, but still tension on the muscle. And what did we say about muscles? You kind of use them or you lose them, don't you? So I always sound like such a hypocrite up here talking about healthy things. But yeah, it's you use them or you lose them. What did we say is the best way to get ATP for our cells? It's called what was that chemical equation I had y'all learn? What was that called? It's called cellular or aerobic respiration. And that is really true. Aerobic respiration is by far and away the best way, and it is what we want to be in at all times, but sometimes we're getting chased by something. So if we are, or whatever, can we go for short distances in anaerobic fermentation? We can go for short distances, but can we go for so long? No, and then when you're done with that, what are you doing? you're in oxygen debt and you're trying to get that oxygen back. Let me tell you what your system is. Your system's got this beautiful kind of built-in ability to go for short distances, to try to outrun bulls and do things like that. But anyway, I wouldn't recommend it. I'm only here because my little dog saved me. I don't think I was actually outrunning that bull, but I think the bull got distracted from the dog. So anyway, I was definitely in oxygen debt at the end of it. So that's the story I remember when I look at this slide. So, but anyway, let me tell you what your muscles have, and you would want to know this, but you already know one of them. You know that in your muscles and your liver, there's stored glucose. What is that called? Well, glucose is sugar, but what is that stored glucose molecule that's called? Glycogen, right? So remember that. Remember that glycogen in our muscles, we have a stored amount of glucose in the form of glycogen, so we don't have to be grazing all day for the aerobic respiration, do we? We've got stored glucose. Now, in our muscles, and you don't know this storage term maybe, but it's called myoglobin. Myoglobin is a protein that is storing some oxygen for you. This is why you can maybe outrun that bull. But do you have a whole bunch of myoglobin? Not enough to keep you going for too long, but you have some stored oxygen. And we say glucose and oxygen is, if they're the reactants in our cells, we can get ATP, can't we? So we have glycogen and we have myoglobin. Glycogen is the stored glucose. Myoglobin is the storage molecule for oxygen. And we can go for short distances, but then we're going to be in oxygen debt, and we're going to have to refuel our myoglobin molecules to get oxygen back on them, right? Are we good with that? So those, you remember glycogen, but now you've been introduced to myoglobin, which is a protein that's actually holding some extra oxygen for us. All right, now, fatigue. Skeletal muscles can get in complete fatigue. Yeah, I wouldn't recommend it, but they actually can. So skeletal muscles will become fatigued if you overuse them. And, you know, they can get to a point that you're in complete skeletal muscle, you're done. You're not going to be able to lift anything, whatever. Some extremists actually think that that's a good thing to do. But you know, because they're trying to build muscle, so they think if they can kind of tear down their skeletal muscle might split and it can help them build up over time. But let me tell you what happens. And we could go back and look at the illustration of what skeletal muscle is, or maybe y'all can just picture a steak, a nice raw steak, which is mostly skeletal muscle. Guys, if you're tearing muscle down too much, or if you have overdone something, you are spilling proteins into your bloodstream. Do you think that's a good place for them? No. And maybe you've actually heard of rhabdomyosis, have you? Where you've got so much skeletal muscle failure that you have proteins flooding your bloodstream, and those proteins start blocking your kidneys. And if they're blocking your kidneys and your kidneys start to shut down, let me tell you what's happening. Every organ system's going to start suffering, every one, because of the toxins that are building up in your bloodstream. So does that sound like that's a good thing? It doesn't sound like it's a good thing because it's not. So I don't know about that skeletal muscle failure, you know, thing people doing that. The thing is, when people are building muscle and trying to, like bodybuilders that are doing it at a logical pace, they're not creating any new cells. They're just enlarging the muscle cells that they have. So it's through kind of genetics what your musculature is going to be like. But you can, with good activity and whatever, you can build muscle, can't you? But when you're building muscle, you're not really truly adding very many cells or fibers. You're just increasing the size of the ones that are there. And that's a good thing. Because if your muscles are being used, then the muscles are going to increase their mitochondria. Mitochondria are going to even start developing. So that's all like a good thing. If muscles are not being used, maybe it's because the motor neuron's been cut, or you know, you're paralyzed, or maybe it's you have an inherited disorder like muscular dystrophy. If skeletal muscles aren't used enough over time, they atrophy and they can be over time replaced with adipose. Right? Okay. Now, cardiac muscle is completely different than this. Cardiac muscle does not use a major difference in cardiac muscle. Let's write the differences because I'll ask you this. See, when I say things like that, some of y'all write this down. Y'all know you're going to see a question about it. Some of you figured that out. A difference between cardiac muscle and skeletal. There's a couple of differences. One of the differences is that cardiac muscle exclusively uses aerobic respiration. So can you go without oxygen to your cardiac muscle? No, this is why blood supply to your heart, blood supply that's supplied by those coronary arteries, those arteries better be open. If they start to get blocked, is that going to be a problem? So that's a major difference. Cardiac muscle has much larger mitochondria and more numerous mitochondria, because do you have to have a constant supply of ATP? Yes. Cardiac muscle is not innervated by a motor neuron. Cardiac muscle is innervated by pacemaker cells. What are they called? SA node. Stands for sinoatrial node. So that's a major difference, isn't it? And that node is pacing the beat of the heart. That means that there's a built-in rest, but there's also large and more numerous mitochondria, and there better be a constant blood supply. Here's another difference. Listen to it. Listen to this difference. For skeletal muscle to have a contraction, what was it? What was that electrolyte that had to act on troponin and tropomyosin? Calcium. And the calcium was stored inside the muscle fiber, skeletal muscle fiber. Y'all remember that part of that story? It's different for heart. For cardiac muscle, they still need the calcium, but for cardiac muscle, it requires more of extracellular calcium to be maintained. So is this another very important reason that blood calcium levels better be maintained? If blood calcium levels are not being maintained, what could it affect? Your heart rhythm. Can somebody be in arrhythmia because their calcium is not, blood calcium is not regulated? Yes. And why does that make perfect sense to us? Because we know that cardiac muscle is going to be more dependent on the extracellular calcium than even skeletal muscle. Does that make sense? Okay. All right, good. So those are some real differences in heart muscle, cardiac muscle, and skeletal muscle. There was another difference we talked about. Well, I just told you that for skeletal muscle, you can get in complete fatigue. You can even tear them if you just are with a fanatic, you know, whatever. Sorry, so that sounded judgmental. All right, sorry about that. But you can do that. But in the heart, and those skeletal muscles can regenerate. Can heart muscle regenerate? No. That was another major difference, isn't it? Major, major difference. Okay. So fatigue on the skeletal muscle might be okay, but not for heart. And this talks about the strength and conditioning, and this is the heart, the differences, and I just went over those. Now, smooth muscle, where did we say we found smooth muscle? We already reviewed this in histology, our chapter for histology, but we said smooth muscle is surrounding organs and surrounding vessels, and smooth muscle is going to control whether it's contracted or whether it's dilated, is going to control the volume inside of the vessel or the organ. Is that right? Did we say that? So that's smooth muscle. But what we also know, smooth muscle, calcium, is coming from extracellular, another reason why we want to keep that level right. But we know that smooth muscle is under the autonomic nervous system control, meaning you can't think about your vessels and say, okay, vessels dilate. You know, it doesn't work that way. You can say, let's write these notes, and you're voluntarily doing that. Or let's leave. You get up and walk out. Don't do that. But anyway, you can do those things, but you can't do that for your smooth muscle. It's going to be through the autonomic nervous system and through hormones that this is going to be coordinated, and you don't have to think about it. We have enough to think about, don't we? So, so that's pretty much that. Now, did I tell you about muscular dystrophy? Your textbook doesn't really talk too much about the other forms of it. They talk mostly about this major, what makes up most of the diagnosis is going to be males, and it's this typical form that we think about. Rarely do they live to young adulthood. This is a devastating disease, inherited disorder. So there are other forms of it, though, and they can affect males and females. And these other forms are usually lesser forms that have a better prognosis. There's also something called Myasthenia Gravis. It is an autoimmune disease. And Myasthenia Gravis, I want you to know it's autoimmune. And I want you to know that the immune system is making these antibodies that look like, they mimic acetylcholine. So if they mimic acetylcholine, it means that the receptors, remember the doorway receptors, the proteins that have to take acetylcholine and open up, except there's already something sitting in the doorway key. So now acetylcholine is being released by the motor neuron. It's crossing the synapse, but there's already something stuck in the key, in the lock. Is something stuck there because the shape of that antibody was enough close to that receptor that now acetylcholine can't cause the receptor to open. So is the muscle going to get a signal to contract? No. Now let me tell you what I hate this not just about certain disorders that they show you pictures, but also I hate it because of like things like sexually transmitted diseases. You know, when infectious diseases, sometimes when you look at infectious diseases, you will see the most horrific pictures, right, in infectious diseases. So people think that that's what all the cases of that disease look like, where most diseases, even infectious diseases, whether they're sexually transmitted or not, are much different than that, you know, much milder than that. Here's what I want you to know. There are a lot of people, and again, this is a disease that, like a lot of autoimmune diseases, affect more women than men. And typically, diagnosis is between this period of time, 20s to 40s, typically. That doesn't mean that you can't see others that are outside this group, but this is typical. And what can happen is you can go years without the right diagnosis because the symptoms can be kind of mild. But what we know it is going to be these receptors are going to be blocked because of the immune system. So with that, it's going to cause some paralysis, and it can come on really slowly, and it can go into remission. Just like most autoimmune diseases, it can be exacerbated for a little while and then go into remission for whatever reasons. And so diagnosis can be really delayed with some of these, but some of the things that are happening first are going to be double vision because the muscles that are associated with coordinating our eyes, like if you're going to be focusing on something that's up close, doesn't it take your eye muscles in your eyes to actually, I know I'm looking really cross-eyed, but right? And then the muscles have to be coordinated to change as you're focusing, right? So you can get, sometimes people say, well, I have like a double vision or shadows, you know, and they say, and then they're like, no, I guess I'm okay. And it can go on, it can be kind of slow, you know. Now, obviously, you can see this person this is so obvious, but also lids can be affected, like the lids can be affected. Swallowing, people will say, you know, I just kind of choke now. I never choked on this before, but it's kind of hard to swallow. Certain things. So you'll see people who have stopped eating certain foods because they're afraid they're going to choke. How many of you have ever choked and it was kind of seriously scared the hell out of you? Has everybody done that sometimes? You know, it's frightening, isn't it? So if you have, and sometimes it's even subconscious, you'll see these patients come in and they'll give this kind of history. They'll say things like that, like, you know, just feel like now it doesn't mean it's myasthenia gravis, but it could be. It could be. And then there are a few patients that will have it and it'll be so severe, the onset's so quick and the symptoms are so severe that it's affecting their respiratory muscles. And there's some patients who get it and they progress so rapidly, there's no way to slow it down, and they don't make it. They die young with this. So most of the cases, though, are the lower end of that, not that extreme. You understand what I'm saying? Now, what do we do for autoimmune diseases? I've been talking about autoimmune diseases so often in here. I've talked about, what have I talked about? I don't know, psoriasis, rheumatoid arthritis. We've mentioned lupus, multiple sclerosis. We've got now myasthenia gravis, right? So we've got all these autoimmune diseases. Nobody's asked me, what do you do for them? Okay.
What do you do for them?
Okay, I was gonna say. Okay, if y'all don't want to know one. No, so really, the sad thing is, it's an autoimmune disease where your immune system's attacking your own body cells. So the thing to do is suppress the immune response. And depending on the severity of the person who has what their symptoms are, is going to, how aggressive you are in suppressing their immune response. What's the problem with doing that? Yes. So you suppress somebody's immune system, and then they can die from an opportunistic disease that they shouldn't have even ever gotten sick from. You get what I mean? So it's a real, nobody wants to throw these kinds of meds out willy-nilly. Do you get what I mean? And every individual is different. You can take people who have the same autoimmune disease, that have the same demographics, they're the same age, they're the same gender, they're in the same ethnic group. They have exactly the same, what seems like close genetics, and have the same disease, but it can present completely differently in those two. You get what I mean? And not just that, the way you treat them, it can affect them differently. So it's a real, it can be a challenge. But what you hope for is that when they're in a period of time that they're reacting, their immune system is doing this, that you can treat them just enough that gets them through those symptoms. But as soon as they go into remission, you can come off, you know what I'm saying? So you can hope that you can get them in remission. Because most autoimmune diseases, people will come in and out of remission for them. Questions?
For their medicine, so when you're suppressing the immune system, it's during like an attacking time, and then when it's remission, are you still attacking the immune system?
Well, so when it depends on like the patient and how the patient's been responding, but usually their physician, they're going to really try to see if they can back off a little bit and see if the person back off of the meds, because we said these meds are serious meds, aren't they? And so they're going to see a little bit. It might not happen, and then they may have to go back up to it. But some people can end up going into some remission, and then not have it to keep a constant.
So like for MS, they do like he has to get a steroid. I forget which steroid it is. So that tastes like the illness.
Yes.
And then during the rest of the time, he has like a medication.
So he has like a medication that's kind of stable, but then when he's in an acute phase of it, he has to bump up.
Well, he has to go in, he has to go to his doctor and say this, and then they usually steroid. He has to,
prednisone?
Prednisone.
Yeah, prednisone is a really common steroid to use. It's a synthetic version of your own body's cortisol. So guys, that's like the toughest, that's the physiology of muscles. You've got an lecture on the physiology of muscles. What I'd like for y'all to have is about a 10-minute break, and when you come back in, then there's a chapter with muscles that's really anatomy, this labeling. And I'll go over that a little bit with you, but I'm mostly going to hand out, when you come back from break, I'm going to hand out this word bank for your muscles, and I'm going to ask you all not to exclaim or scream when you get it, because I'm going to go over it with you, and there are a couple of things I'm going to tell you about it that I think are going to make you feel a lot better, okay? So take a 10-minute break, and we're going to come back and look at the anatomy, which is just labeling muscles, okay? Take a 10-minute break, and then we'll come back. All right, so this list, guys, there are a couple things I'm going to get you to mark off of this list, but then I'm also going to let you know something else. So let me tell you which ones to just mark off because actually a couple aren't even muscles really. It's just areas I want you to know. So if you notice they're in alphabetical order, right? So they're in alphabetical order. So if we go down to the L's, the Linea Alba, this is like a connective tissue type of tissue that goes from the pubis, which you all know where the pubis region of the ospux is, up to the umbilicus region, or umbilical, if you like to call it that. But anyway, it's this line, this white line that, you know, obviously you don't usually even see it, but sometimes during pregnancy, what can it do? It can darken. It's called linea negra when it darkens that way. So I had that, but mark that out. I'm not going to have that. And then go to the quadratus, the Q's, quadratus lumborum. But where would you be looking for this? The lumbar region, the lower back. But mark this out because we don't really have any, I don't have any good pictures of it. So we're going to mark this out. Then go down to the sternohyoid. Again, hyoid bone, do you know where that is? Mm-hmm. Yeah. But we're going to mark this out because I don't have any great pictures. And then go down to the umbilicus. And we're just going to mark that out as well. All right, look. Now, that's it. Alexis is like, what? What? Wait a minute, we're not done yet. So, yes, we are. No, look, let me tell you what. I don't know how many end up being on here, something like 70 something. But anyway, look, but this is the paper that I'm going to give you when you have your muscles lab. You don't get to have yours because I know you're going to write all over yours, right? But I'm going to give you this very same paper again. And let me tell you what you need to do between now and when you would do this muscle lab. You're going to need to do 40 of them. I don't care which 40, but you're going to need to do 40 of them. That means, you know, you do 5 a day for the next whatever, and you've got it in how many days? 8. So, you know, is that really too bad? So now we're taking a deep breath, and we're thinking, okay, all right, we're taking a deep breath. Now, look, what'd you say?
So you'll give us all of
I'll give you the list.
Get 40 of them.
Yeah, but you will only be using 40 of them. And let me tell you how you're going to do it. Just like y'all know how the bones are going to be laid out for you, right? Let me tell you how you're going to do this. I'm going to, when you come in for the lab, the muscles lab, I'm going to give you another copy of this. You're going to probably, I hope you're going to have looked at every one of them and gotten to the ones that you feel the best about, the top 40 that you feel the best about. And I'm going to give you pictures. They're not going to have, I'm going to try to find one with not even any lines, but I don't have all of them like that. But anyway, so they have lines, but they don't have, obviously, on label. But it's going to be these colored illustrations, right? So I'm going to give you, I think it's 4 pages, it's 2 pages back and front, of these colored illustrations, right? So one of like the face and the side, and you know, of the trunk, front and the back and the leg and the arm.
There should be some.
Yeah, but y'all see what they mean. I'm not going to give you cadaver pictures, am I? I'm going to give you these, not the cadaver because that's too hard, but pictures like this that are colored. Now, I want you to pay attention when you all are looking at your muscles list and you're trying to learn about 5 a day or more, you know, whatever, get them down. I want you to pay attention to the pictures of where muscles have been cut, because sometimes you'll see that they've been cut and this muscle is superficial, but the superficial one had to be cut so that you could see the deeper one. An example of this one, well, this is an example of the buttocks, really, the gluteus maximus. But you have to, which everybody knows is their butt, right? But you have to cut the gluteus maximus to really see the minimus, right? You get what I mean? Another example that I think is just a great example, I didn't really give you some of these pelvic floor muscles, but just because I didn't have, maybe I should in the future, but I didn't put those on your list even. And I don't care which 40 you do with that, you can do any of them. But let me, the ones as far as cut, let me tell you again. All right, so this is a great example of one, like in the lower leg, the gastrocnemius is calf muscle. Everybody can feel their calf muscles, really superficial, right? But if you cut that, if you cut the gastrocnemius, underneath it is the soleus. And this soleus is often injured, right? So when you label these muscles, you better be labeling them correctly. If I have to guess which line, I can't be doing that, because look how many of you all, and I have to look at 40 for each of you. You know what I mean? So I don't want to be guessing. I want you all to know at least 40 well. But I would hope that you would have looked at all of them, right? Let me tell you something else that I think is going to make you feel better. I did, okay? Because this list at first, you can imagine the other students looking at, finding this list and thinking, what class is that, right? Looks kind of like a foreign language, but you guys know. So look, brachii. If you ever hear brachii, what are you talking about? Your arm. How about femoris? The femur, right? The biceps part means how many heads there are. Now look, when y'all look at the pictures and you look up the biceps brachii, the biceps femoris, if it ever tells you like a lateral head or whatever, you don't need to know that, do you? You just need to know that that's where that muscle is, right? How about if you saw brachioradialis? The radius is what? So yes, so this is the radial. This is this sort of plump muscle right here on the radius, right? So are the names helping you if you know regions and if you know bones? Mm-hmm. And there's going to be at least 40 of them that should be really kind of easy that way, right? Here's what I want to bring to your attention too, and I'm sorry to kind of all spread out, but you'll look at external abdominal oblique, then you'll see internal abdominal oblique. Do you see that? And then you'll see transversus. Do you see transversus abdominis? Guess what the external, the internal mean?
Inside, outside.
Thanks. So look at the cuts, right? That's easy. That's easy. And well, guess what oblique means? The striations. Pay attention to the striations. They're going at a slant. Where if you look at the transversus abdominis, guess how those striations are going? Straight across. And guess where you're going to be looking? In the abdomen for a muscle that's got this straight across, right? Now look, you also have something called the rectus abdominis. Where is that? Under the arms. The rectus abdominis. The rectus means like a straight kind of muscle. That's what people call that washboard, that six-pack, right? The rectus abdominis. All right, so let me tell you what I would do if I were y'all first with this list. You don't have to take my advice. But I would take this list and though, it's an alphabetical, but if I were you, I would take each of them and put them in regions, like all the ones that are in the arm, I would have them down, a list: arm, legs, abdomen, back. All right. Let me show you and give you a hint about one this is, you're going to see this and it's going to make me really crazy because I'm going to have some of you that aren't listening and you're going to do this and I am going to just worry that you don't know, okay? If you see one that says abdominis, like the external abdominis or the internal abdominis obliques, what picture are you going to be looking at? The one in anterior aspect, the front, right? If you look on the back of somebody, you can see where these are inserting. So if you label the abdominis muscles, where you see most of them, you see most of the muscle in the front, if you label it where it attaches on the back, I'm going to think, bless their little hearts. It's the same thing. I mean, I have to give you credit for it because it would be right, but I want you to kind of really be making this easy for yourself, right? Make it easy for yourself with the names. If you see one that says latissimus dorsi, dorsi means what? Dorsi means back. It is the broadest sheath muscle of the back. Now, can you see a little bit of it from an anterior view? You can, but don't label it there when the whole big old muscle's on the back. Oh, okay. And it's going to make me realize that you really know where the muscle is. If you're labeling it here, I'm thinking, so they really know that that muscle is that big, huge muscle they have a big drug right here. You know, so try to do that. Pay attention to how deep things are. The platysma is this muscle that's a really superficial sheath muscle that I need to work on. You know, so this is the platysma. But if you removed it, you've got the sternocleidomastoid muscle, sternum, mastoid process of the temporal bone, sternocleidomastoid, this really thick muscle, but you have to remove the platysma. Okay, so pay attention to depth. Pay attention to the names will help you to know where they are. They're not as hard as you think. You'll get to 40 before you know it. You will. I would hope that you would have looked at all of them, right? The zygomaticus, minor and majors. Where are you looking? Chiefs. Very good, right? Yeah. So, so guys, do you feel better about it? Do you feel better about it? No kidding. Okay, good. I'm trying to think of any others on here. But you can pick your 40. So, I mean, if you look at one and think, oh, that's crazy, I'm just going to mark that one off my list. How about occipital? How about the ones that are so obvious? Frontalis, temporalis, occipitalis, right? So, you know, there's some that should be so obvious to you right now because of bones. How about anterior tibialis? In front of the tibia, right? Okay. So do you feel better about muscles? I know people are scared about muscles at first, but then you see that, and hopefully you feel better about your list. This is your word bank. You will be doing 40, and you will have quite a few pictures that are the illustrated colored pictures to choose from to find your 40. You label your 40, and you're done. Right? But do you have, can you wait till the last minute? No, don't wait till the last minute. Don't do that. All right, so that's that. And we have really finished this section of bones, joints, and muscles. Would you all like to ask any questions about those? But just take a few minutes, go back through your notes on bone physiology. Do you think you're going to need to understand those hormones, calcitonin, calcitriol, and parathyroid hormone? Are you going to need to know which glands secrete them? Are you going to need to know what they do to blood calcium levels? Yes. Are you going to need to know bone cells, osteoblasts, that become osteocytes, and osteocytes get torn down by special bone cells called osteoclasts, because osteoclasts secrete hydrochloric acid. Okay, I don't know. What? Do you have any questions about bones? Joints are mostly understanding some terminology, but also those movements. Are you going to get multiple choice questions about the movements in joints? Yeah. Yeah, you are. So that, and then muscle. If you know the muscle story, which you actually have to know by Tuesday, the muscle story. So certainly by the test, which is what, Thursday, you know, you're going to be able to answer several questions about on the test if you just know and understand that muscle, skeletal muscle story. I call it a story because it kind of is. Does anybody have any questions?
So, I assume chapter 10 and chapter 11 will need to know the deeper insights.
So, yeah, so you want to look at deeper insights, even though there are a couple of chapters that are in this that are really just anatomy, mostly anatomy, but you still want to look at the insights. Good question. Yes. And how many of you are keeping your insight notes and your disorder notes kind of separate? It's really, I think that's a really smart little tool to do, because, you know, for the final exam, that's all you would have is the final exam is just going to be insights and disorders, which you have been studying all along, but okay. All right, so you guys ready to move on then? Huh. You're like, wait a minute, let me take a breath. Look. So you understand that when I'm starting the nervous system today, I don't expect, and I'm not going to put up a study guide thing for y'all to do today. I'm not going to put up a study guide thing. By the way, and I hope y'all don't think that's like punitive. That's supposed to be helping you. Some of you are not keeping up with it and not using it for coming in, and that's up to you, because you can decide that. But it really is so y'all can get help from other people and feel like you're actually kind of learning the same process. But I'm not going to do one today because I know you have next week coming up. I will post the lecture from today. I will certainly post the lecture from today, and whatever. But you're not going to have a study guide to do on Tuesday. You got to be ready for your bone quiz. Does everybody remember that you do not get a word bank? Does everybody remember that spelling will count? Okay. And you will have the muscle story. Okay? All right, so we finished this chapter. I actually would like to kind of just stop this recording at this time, and then I'm going to start another recording for the nervous system. So I'm stopping this